Can I talk about how type info differs from RTTI in C++? I don't use RTTI in C++, but it's very limited. Like, it doesn't give you the info that you want. Let me put it that way. Actually, the other thing I'm not up on is what C++ does in like C++ 14 with templates. So there might be a templatey way to like spit out all the names of things, but it's probably a gigantic mess. I don't know. The features of C++ that I use are limited to a relatively clean, relatively fun subset, which basically doesn't involve templates because templates are so horrible. I use them minimally, when I have to. How do I? Okay. Regarding notes, have I considered making these any rather than string? They're not really a type string in the language. They're like I guess they would be. The thing is, if they're in any, then they have to be in the syntax of the language itself. But I want you to be able to make anything that you want. Like, if you want to put, TI-99 reverse Polish notation computations in there and then parse them out and run them yourself, you should be able to do that. I mean, that's a stupid example, but I wanted maximum freedom because, again, these are for you. They're not for the compiler. So, but we'll see, as people use the language, we'll see what people tend to do with it and go that way. Someone's asking, why have implicit sizes for float int? I believe what's being asked is, you can say a float, right? Or you can say A is float 32 or float 64. And why not make people say 3264? The reason is, so by the way, in this language, float is well defined. It's float 32. An int, maybe I should make it float 64. I don't know. Int is actually, S64. Maybe. It's going to be S64. The reason I do that is because intent matters, right? And communication matters, right? If I say something is an unsigned 32-bit integer, it means I thought about it and there's a reason why it's unsigned 32 bits, right? Like that's big enough or it needs to fit into a certain place or something like that, right? But sometimes I'm just writing code and I just want a big number and I don't want to think about it, right? So if I say S64, like it's a signed 64-bit number, maybe that just means I didn't want to think about it, or maybe it means it has to be signed 64-bit for a reason. And I wanted to differentiate between those two cases, right? So when you say int, it means I am not really thinking about overflow or fitting this anywhere or anything like that. It's just a number, right, that I want to play with. And if you designate the size, then hopefully that means that you've thought about what you're doing and there's a good reason for it. Yeah, someone's saying they think it's super cool because it's not complicated. I agree. My main design goal as I'm doing this is to try and be as simple as possible with a language that's as fast as possible, but also much more powerful than C or C++ even. And we're getting there. We're not there. We can't say we're more powerful than C++ yet, but we will before too long. And any variable can be of any type at any time. Yeah, that's true. Are you allowed to constrain varargs to a specific type? Currently, if you wanted to do that, you could do that with a check function, right, that gets invoked at compile time. There's no way in the header of the function to specify the type. I think if you want to do that, you might be more interested in polymorphic functions than vararg functions, or maybe there'll be like a polymorphic vararg variant, right? Who knows? That will probably be an option, right, is where you could generate a function. So any is a little bit loose, right? It's like the code that you're running checks the type at runtime and checks the pointer and does something with it. If instead you use that to generate a more hard-coded version for each type, or you use some equivalent of templates to do the same thing, then you're being much more specific about the type in a hard-coded way, right? And so, I don't know. We'll see how it evolves. Right now, you would use a check function. How does building the type table interact with the dependency resolution system? Does it preclude dead code elimination? Here's the thing. I don't think dead code elimination is very important. It might be if you're linking massive, gigantic libraries or something, but why are you linking massive, gigantic libraries in the first place? But the thing about dead code elimination is, you know, it prevents you from looking things up at runtime. Like maybe I want a function in my executable that I could look up at runtime. Then you have to specify that as an exception. I don't know. You know, honestly, I'm saying this and I've never had to deal with dead code elimination. So maybe I won't like not having it if I don't do it, and then I'll decide, oh, dead code elimination is important. But in terms of types, so right now, that type info table is being generated by the compiler, and it fits mostly very naturally into the dependency resolution scheme, because in order to use some type, you have to know what it is. So the dependencies are already set up so that you wait on other people to get resolved and inferred and stuff, and then you go. So, you know, there's always a couple of little wrinkles, but it mostly just slots straight in the compiler. Now, if you have a function, if you did have dead code elimination, and you have a function that doesn't get used, you might eliminate that code and still have the function there in the type table. And it's not clear to me whether that matters, and whether it's desirable to eliminate it from the type table or not, because you might, even if you're not using that function right this second, you might use it in debug build, right? Or you might use it. You might not be using it right this second because you just commented out some function call because you're trying to figure out what's going on with your program, or you're exploring some variants of things, and maybe you don't want that type table to flail around while you're making these small changes to your program, right? Maybe you do though. Maybe it's a build setting where you say, oh, optimize the type table. Now, I said right now, everything in the type table is handled by the compiler, and the reason I say right now is because that makes sense, because I'm only dealing with one compilation unit right now. If I want to use all these facilities in a library, right, the library's got to have its own type table with its own indices, and then somehow when you link to that library, right, both those type tables have to live alongside each other and work. And how does that happen? Well, we'll see, right? But it probably involves participation of the linker in some way. So we're presuming that we're not using a dumb linker like a C linker that doesn't know anything about our language. Oh, the other thing, right? I said that you're guaranteed that types are unique in the type table, right? Well, you know, that library's types have to link back to my types or correspond or something if I'm going to be able to use that equals operation, right? So the linker needs to take care of that, because when you compiled the library, you didn't know what types were going to be in your program. So there's another step. I've introduced a little bit of technical debt here, that when there's a linker that handles separate compilation units, it has to handle this facility, right? And that hasn't been implemented yet. But then if you wanted code elimination, then you could do it using that same step in the linker to remove things from the type table that would handle library linkage and stuff. Sean saying, my simple any example allows a colon n equals 3. Yes, it does. I did that in one line in the program. I don't think there's a question there. Have you ever looked into Common Lisp's quasi-quotation? Yeah, I mean, I used to program in Lisp and Scheme and stuff a long time ago. I don't like it. I mean, I liked it in college, but since then, my tastes have swung 180 degrees in the other direction. Someone's asking any possibility of typed varargs that is similar to the question I just asked. I don't think it's that important right now, but if a need arises and it's a really legitimate need, then I would do it. It's just you have to wait until the other features of the language come into line, because maybe something that you would have used typed varargs for is more appropriately done and more easily done and straightforwardly using a different facility. So I want to wait and see what happens before I start putting in more features. What about typos in notes like no serialize? Well, at compile time, you could have a list of notes that you expect, right? And you could scan all your types for notes and complain if there are any unknown notes. Now, again, if you have some other compilation unit, like a library might have notes that you don't understand. So you need to check whether something comes from your module or someone else's module or whatever. And there aren't modules yet, so that'll happen in a little bit. But if you're just talking about your program, then yeah, you can validate your notes just the way you could validate anything at compile time. Since C++ is kind of drudgerous, am I planning on porting the compiler to this language? Yes, eventually, but as much as I would love not programming in C++ anymore right now, I also want to program in a language that is actually stabilized, and I don't have to change the thing all the time, so I'm going to wait a little while. Also, having to program in C++ to do stuff like this gives me perspective on what exactly is a pain in the butt that I would like to work better. Question, so when I write at, where does it look for the cases? How does it look in a specific function? And how do you know where that note is located? Okay, so that note is located in the metadata for the declaration, right? So if I put a note on this struct, then in that type info array, there's a type info that says party member old is a struct, right? And on that type info, there's an array of notes that says, oh, here's a note, version 7, right? This struct has a bunch of members, and each member has a thing that's like, oh, here's a type of what it is. Oh, and here's also some notes, right? So basically, if you were to say to get at the notes array directly, you could say type info of party member old, right? Dot notes sub 0 or whatever, right? That would give you, as long as there were elements in the notes array, that would give you this version 7, right? String without the @ sign. So that would be equal to version 7, right? And then you could parse the 7 out from the version to know what version it is and stuff. I chose to put the type info in the pointer, but it could be convenient sometimes to put it in the object itself. No! 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 No. Does that make the loop variables always 64-bit? Is that as fast as 32-bit loop counters? You can specify your loop counter as any type if you want. The default is 64-bit because computers these days tend to have 64-bit processors, and a register is 64 bits wide. And I chose that, hey, let's have good behavior for large files. Like, if you're 32-bit by default and you want to iterate over every character in a file, your program will break after like 4 gigabytes, right? That's not good. A 4 gigabyte file is not that uncommon these days. So, it should just work. So if you were to somehow go back to an embedded processor or something that's not 64 bits, everything will work fine. You just want to be specific about what your loop counters, what type they are and stuff, which tends to be the kind of programming you would do on an embedded processor anyway, right? You tend to be very specific about things because it's a very low-end kind of programming. And that's all fine. It all works. I could make notes their own type, so I could implement a constant time equal operator for them. Actually, they're already unique. So you could cast them to a pointer and compare. They already get interned as unique strings. So that could just be in the spec or something that like, hey, compare them by pointer and you win if they're the same. Because I'm trying to keep that type info table small. So if you put the same note a bunch of times, I don't want to store it a bunch of times. I just want to point to it a bunch of times. Is there any way the code run at the compiler could affect the notes or even members of a struct? So right now, the way you could do that, you can't ever change old data yet. So you might have some struct like party member before, right? And then maybe I can look at that in memory and create a clone struct called party member after. That's a string that I parse and then add some notes to the string, right? And then my program would know to use party member after. That would work today, and I was going to do a demo of it, but I felt like I would save meta programming kinds of issues for next time, because that might be a focus, because I'm going to do some interesting facilities there. Now, you might imagine being able to actually walk along the tree of the type info and change it, and maybe we'll do that. I'm just not sure what is really a clean way to do it that's going to be simple and not confusing and powerful. If I think of such a way, we'll do it. So if anyone has suggestions, if anyone has suggestions of how to edit the syntax tree or something in a nice way, you can email me here. This is not a mailing list. It's where you can email comments and suggestions. No syntax comments, please. Opinions on size t. There's a size of. I didn't demo it today, but I have size of in this language, and it just returns an S64. So I don't like size t is just for, as far as I'm concerned, if you're dealing with really small numbers usually and you need a big number. But if your big numbers by default, who cares? Like, you're not going to have a data structure that's bigger than a 64-bit integer is high. Like, that's, at least I hope not. Maybe I'll be eating those words someday. But as of today, there is no size t. It's just signed 64. And the reason it's signed 64 is because I said, why not just give you the ability to pass -1 sometime to mean, an error code or I didn't set this yet or, uninitialized whatever. Could there be a compiler option to embed the compiler in the executable? Why, there will be, yes. I haven't done it yet. Wouldn't it make sense to have notes of type any and support any constant expression for them? Then you could probably have something like version 3,7. Version 3,7 is not an expression, though. I mean, yeah, maybe. Like if that's what everybody would prefer, we can end up doing something like that. But I don't feel like that's the right thing. Like I said stuff like version 7, right? Like that's not an expression, it's an identifier. Like the 7 is not an integer, like it doesn't, I don't know. And it wouldn't parse in the language, like this is not a valid thing, and you want to be able to say stuff like that. So I don't know, but we'll see. Like I said, this is just my idea about how these things might be used, and we'll see in reality how they are used and make decisions accordingly. Looking for more questions. Someone's recommending I look into how Go does tags. It does the same thing in a slightly different way. Go's caveat is that tags are only for fields on structs and not for type or variables. Okay, I'll take a look at it. There's so many languages out there that I try to keep informed and look at what they're doing. At the same time, I'm working on 2 very large projects, right? I've got this compiler, which is my spare time project, and then I've got the game I'm working on, which is a 200,000 line program that we're trying to ship soon. So sometimes I don't do so much reading. But yeah, I'll look into tags and Go. Any plans to support various functional programming capabilities? Not really, not in the way that you think. Definitely, there's a certain problem space that functional languages are interested in, which is how do you make code that's safer and more parallel? And I'm interested in that too. I'm interested in how do you make code safer and more parallel, but I don't subscribe to the functional language ideas of how to do that. I think they've been shown not to really work yet. And a great deal of more research is required before they really work for the kinds of software that we're talking about, which is performance software that is simple and code that you can read and easily understand what it does. I get comments at this mailing address all the time from people who want functional things, and they're not generally driven by use cases. Like, they're not generally driven by, like, I need to do this very specific thing, and in C++ it's hard, but this other way it's easy. No, it's usually just like people who like language features and want to see these features, and that's not, I think, a good way to make decisions about what your language should be. What I'm trying to do is make a very pragmatic language that solves very specific problems that I and other people in my industry have. And I don't see most functional language concepts as being very applicable. Except generally the idea that reducing side effects is maybe good, right? Okay, yeah, I buy that, but I don't really buy the way that they do it. So we're going to look into some other ways of doing it that I hinted at in the early talks, and that I have more specific ideas about, and we'll see someday. Could I allow the user to add fields in the type in? Okay, I already answered that. How does any interact with fat SOA pointers? Exactly like you would think. So an SOA pointer, right, is a pointer type. I'll show you in the. So if your pointer is SOA, right, then when you read the type info, this type is pointer, right? So you cast it to type info pointer. And type info pointer has a pointer to the base of the array, right? And a thing that tells you the packing. Well, you know, it's a base of the array if it's SOA, and it's a base of actually, sorry, it's the base to the. If we're talking about an SOA pointer, this is the address of the pointer, right? So you would dereference this to get the SOA pointer, and the SOA pointer implicitly contains the array size and length, position information. And this tells you what it is, right? So -1 means it's a conventional, you know, in order value packed struct, so it's not SOA. 0 is the SOA that I demoed last time, and I've left some space open to do AOSOA of varying chunk sizes, right? So if this is 16, it would mean AOSOA of chunk size 16. Now, I haven't actually implemented that because I'm not sure how to do it without maybe making SOA uncomfortably complicated. So, or I don't know. We just have to look at it a little bit, and I think having some future language facilities may help us do it better. So I want to get those future language facilities and then come back and visit things like AOSOA, right? But it's basically the same as a regular pointer. It's just this tells you it's SOA. If you generate new types during compiler time, will it get included into the binary to get access at runtime? Yes. Okay, so this is an interesting point. So you can query all this type info stuff at compile time or at runtime, right? And at compile time, as I've demoed before, you could compile your program in stages, right? You can run a build function. Like if I go to the, let me see if invaders still includes. Okay. Wow, I'm including them twice. Anyway, so here's the old version of the build function that I demoed, right? So you might start building and only have this function live, but you might do type info inside this function, right? So when you start up at your first compile time pass, you have to have a valid type info array for anything in the program. Then as you add these build files and return back and let the compiler do more work, new stuff is going to get compiled. And what happens is those new types just end up at the end of that type info array or get unique. Like if they're equal to anything earlier, they get pointed at the earlier thing. But if they're later, then you know, they're later. So Yeah. So if you were to store a pointer to a type info early in this process in a global and reread it later, it would still be valid. So the types from an earlier pass do not move and do not get invalidated. They only get added to with every compilation pass. I don't understand why people want notes to be any's. If you really think that, send an email and we'll talk about it. I don't understand that desire at all. How does type info work with using accessor function results? Well, what happens is you get two things. Let me go back to basic. So there's two flags. Hopefully I remember to expose them both. On a struct member, I didn't expose it. Drat. Okay. I forgot. Okay. All right. I think internally even, I think in the C++ side, it actually sets these flags. They're just not in the header file. But on a struct member that is being used, right? So if you say using name, right? Then on name, there'll be a flag that says this is a target of using, right? But then also in that outer struct, or name is dumb, like using vector3, right? Because that has components x, y, and z. So on that vector3 declaration, you would say, get something that says this is being used. But then also on the outer struct, you have the imported x, y, and z. And you would get a thing, oh, that's what imported means, right? So I at least added one of them. So on that x, y, and z, you would have an imported flag that says, oh, they don't actually get stored in this struct, right? They're imported by some other thing. And because they're imported, then you know not to store them yet or something, because you'll store them when you go visit the other guy. I didn't handle that in the examples because it's a complication that you probably only get in like real production code. But all that stuff, basically anything you need to carefully navigate your data structures in a highly professional way will be provided. I have thought, someone's asking, might it be interesting to have the compiler use some notes so you could instance mark types with exclude from type table? Maybe, and I've thought about that. In fact, the lexer and the parser understand notes that have double @ sign. And the idea is that double @ sign means it's for the compiler. So that is in the language. It is just simply not used currently and may end up being used, or maybe we'll do something different. I don't know. It's just I don't want to have too many ways to describe things. Like we already have like compile time directives and like stuff that's not directive, like inline and using. And it's, at some point I have to sit down and say like, what's the right way to express all these different things, and how many different ways do you need to express things? So maybe if it's for the compiler, it's better to just have a word like inline or using, and I don't know, maybe not. I think your question did get cut off. I was saying that being able to reassign the type of an any seems bad. It wasn't necessary for any demo other than demoing that feature itself. Like my immediate reaction is that the type of an any should be immutable and must be defined where the any is declared. Is there a reason not to do that? I see many potential problems for a reassignable any type. Well, maybe. That could be a very legitimate concern. What I would say right now is that there is almost no code using this exact facility, so it's a little early to say exactly what the problems are. That could very well end up being one of the problems. Now, if it is, I'm not sure that the best way to solve it would be to make any some exceptional case that's read-only. So for example, like one pattern that you have a lot in a language is maybe when I initialize a struct, something gets set and then it never gets changed, right? So you might have an intrinsic called like, you know, set once or something. You know, that's not a very good name, but you know what I mean. Like, let's say write once, because I might have things like read only and write only, and if you say something is write once, then maybe that enables optimizations, right? Because even if some aliasing is happening, you might know in your function that even if somebody aliased that and wrote to it, you declared in your program that that would never happen, so it shouldn't have happened. And we can be faster, right? So if you did that, then you could say, you know, x is a write once any or something. You know, this is a very ugly syntax, so maybe you wouldn't do it that way, but I'll just say I'm thinking about these kinds of problems and trying to find the best overall way to solve them, and we'll see. How important is, I don't know. I'm ignoring a syntax question. Scrolling down. About those loop counters, not thinking embedded system or 64 gauge. Yeah, I mean, anything that where you want smaller loop counters, you can say, in this, I did a lot of like for array ... right? And that gives you an implicit, that is the same as saying for well, let's assume, I don't know. It automatically gets made the type of the array, but you can declare the index, right, as S64 array ... So you know, you can do stuff like this. You could say, oh, it's signed 8-bit. You probably want to go unsigned if you're that small. But that all works. You can rename these, right? You can say x and index of x, like whatever, right? Also, if the array actually stores integers, you can specify what type it should be after you pull them out, as long as it'll implicitly cast. I think I understand why you put the type info in a pointer and not in the object, but no. The reason is because there's immense complications caused in C++ by this fact that C++ can invisibly wedge stuff into your storage, and that's supposed to be fine. Like, now you have this idea of plain old data types and non-plain old data types and garbage like that, and like you can't mem copy one thing into another thing, and it's you take a large complexity hit for something that's supposed to be a simplifier, right? It's supposed to simplify life, that you don't have to think about that thing, but what it in reality does is dump complexity into the rest of the language. I don't want to dump complexity into the rest of the language, so I want to avoid that kind of a thing. I don't know. That's as much as I want to go into that. If A is an array of vector 3 and any is filled with a couple of vector 3s, could I just set A equals any and have any fill A with its vector 3s? I think I don't currently do implicit. Oh, no, that won't work yet because I don't even do array assignment yet. So you can't, even if the arrays were the same type. Oh, no, maybe it will copy them. Maybe it will copy them, but I may not do that implicit conversion if they're different types. But I think that's a reasonable thing to expect in the final language, is that that would work. Because, you know, if you have an array of like unsigned 64-bit numbers and you assign it to an array of unsigned 32-bit numbers, like it's pretty obvious what should happen. And maybe that should just happen. What are my thoughts about making array -1 indexing the last member of the array, array -2 the second to last, and so on? That is a slow feature language, unless it only works with compile time constants, right? If it's a compile time, if you literally say array sub -1, then that's fine. But if you're saying array sub I, and I is an integer that could be any value, then you have to now put if statements every time you index your array, and that makes your array accesses slower, and I don't want to do that. Could I make a compiler error to dereference to type info pointer if the storage was disabled instead of crashing? Yes, I could, and I will do that. It's not done right now. The question is just whether that could be caught in all cases, because you might cast your type info to something else for some reason and dereference it later, and that might be very hard to catch. In fact, it's the kind of thing that compilers eventually can't catch. So, but you could get coverage for all obvious things. Like if you have a thing that's of type info or any of those subtypes, and you try to dereference it or subscript it or whatever, then yes, that can be caught at compile time quite easily. It's on the to-do list. It's just relatively low priority. One of Ryan's students, hey, how's it going, man? Did he tell the class about this? That's weird. Is type info evaluated at compile time? Yes, it is. That is a purely compile time primitive. How can we program print any, for example, to work seamlessly between embedded and desktop? It just would work. There's no different. All the code that I showed is platform independent. It'll just work. There's no problem. That's the whole point. I like the dot operators, like Python's list explosion operator. Would dot work with non-varargs if the arrays are the right size? I've thought about that. It wasn't relevant to this demo, so I haven't programmed it. But you could think of that as a thing that you could do, right? Like if something takes an array of 5 things as an argument, you could maybe pass it 5 arguments and put the dot in front, and the compiler would know how to do that conversion. That's pretty straightforward. If people think that's an important feature, we can do it pretty easily, and it wouldn't complexify the rest of the language at all. Those are the kind of features I like, are the ones that don't combinatorically mess you up. Of course, whenever you're designing something complicated like this, you get surprised sometimes, like, oh, I didn't think that thing would complicate me, but then later I did this other feature, and no, those 2 features want to fight, or they want to combine to make something beautiful. Like, all these surprises happen, so we'll see. Like I said, right now I'm basically doing features in priority order of some combination of how powerful they are and how quickly I can implement them. It's going well so far, and so I'm going to keep following that policy. You could make the serialization code work in embedded system without the type info. Yes, you could, because well, you would need to do it at compiler time. Is the thing. So secretly, okay, here's the thing. All the demos I showed today, you might think they were like runtime code, and they would be. They would work the same. But I don't have a native code backend right now because I ditched the C backend and I'm not done with the LLVM port. So everything in this demo is actually running at compile time, right? This run main down here means this is running in the compiler itself. The compiler is running all this code. So instead of like printfing all this stuff, I could have put together a string that has code in it and included that as a compilation unit, right? Or not a compilation unit even, but an extra, just like a file to compile into my current compilation unit. I didn't demo that. I could have. It would have worked fine. You've seen, if you watch the earlier demos, everything that you need to do that. If you're on an embedded system, then you would have all that type information available at compile time. So you would be able to walk over the members of the struct at compile time and then generate a function that serializes the struct from those members, right? So then at runtime, you don't need that type info. You just made a function that's very hard-coded and hopefully very small and fast. Since intent matters, what do you think about a stricter type def-like construct? For example, vector3 is screen relative position. Making it, okay, yeah, I've thought about that. Being able to type def one thing as another thing and making them not implicitly cast between each other, right? I think that might be important. I don't think there's a way to express that right now. There sort of is if they're both structs. If they're both structs, right? Like say I wanted to make a vector3. Let me look at my vector 3, right? So say I wanted to make a vector 3, or here's an example. Here's a real world example. I have a vector 4, four-dimensional vector that's just Euclidean space stuff, right? And then I want to make a quaternion that doesn't cast to vector 4, but that has all this stuff. I could do this right now as sort of a hack. I could say this is a struct that is using v vector 4, right? So quaternion and vector 4 would not cast to each other, but you could say, you know, Q is a quaternion. And then if you wanted to use the vector, you could say Q.V, right? Or you could just say Q.X and Y and Z and W. So this would work right now. I don't know if it would work for every case. Like, I feel like you don't just want to do this hack, like you maybe want real type aliasing. However, type aliasing is sort of involved with some other features that are going to come later. Yeah, we'll see. We'll see what it looks like as that stuff starts to roll out. And I don't think that's just intent, actually. Like, I think that's part of making a robust program, is you want to be able to do that. Like, you could say, you know, I have a float that's I could say meters is like some strongly typed float, right? And feet is some strongly typed float. And then I could have a function that takes feet or a function that takes meters. And if you try to pass the wrong one, you'll get a compile time error, right? You want to be able to do that. How do I feel about const by default? I've thought about making parameters const by default for performance reasons, and, you know, mild safety reasons. I don't know if it actually helps, actually, because if a parameter is const by default, if it's too big to be a value parameter, it's essentially a const reference, and you know, it's basically a pointer which reintroduces all these aliasing problems unless somehow you can communicate across function boundaries that it's absolutely under no condition is it aliased, which you might be able to sometimes, but I feel like that's the sort of thing compilers already do, and they're known to still have problems. So I don't know if it'll help. I'm interested in experimenting with const by default and seeing if it's helpful. Can you identify function pointers via type info, call them, do varargs complicate this? Yes, you can, and no, they do not complicate them. It works exactly as you would. So let me rerun the very first thing in case people forgot. So the very first thing I did is iterate over the whole type table for the program and print out every type. So you'll see function types in here as well as pointer types and stuff, right? So here's a function that takes an array of any and a string and an S32 and returns a bool, right? Just like I have an array of 1,000 U8s or whatever. These are types that are uniquely represented in this table. So if you pass a function to a varargs, you'll get a type info that points at one of these. It's just like a struct or anything. That's why it's so powerful, is it works on everything without exception, right? Where languages start being terrible is when they sort of work, but this exception and that exception, and you can't do this and that under whatever condition. Like, screw all that, right? Things should always work unless there's very clearly a reason why they absolutely cannot work, and why you would obviously know that they wouldn't work in a certain situation. So, yeah. I think people want any notes because they want some nice way to get non-string data without having to write parser code. Yeah, maybe. But you know what? Like, you could probably just have a function in the standard library that'll parse a note to an any. Like, I feel like that's something we ought to be able to do, especially at compile time. Like, you could compile time, well, no, because it'd still be notes out the other end. I feel like that's doable. I don't know. Maybe it would be a subset of any's. Like, I don't know if I want to let you compile a function. Maybe. I mean, if you link the compiler like as a runtime library, then you could compile code and relink it and stuff. I don't know. We'll talk about it. Like I said, if that's the major use case, if mostly people don't want to parse their own thing, then we'll talk about it. Maybe there's even a different syntax. Maybe you could get a note as an any or as a string. Like maybe if you say at, that's a string note, or maybe if you say at, that's an any note, and maybe if you say at quote, it's a string note, or I don't know. Maybe there's an ambiguity there. We just have to figure it out. Unsure if he told any of the classes about this. I do independent projects under his supervision. Okay, cool. Right on. I like his stuff. So good on you for working with him. Instead of making notes maybe have some common note parsing functions. Yeah, like there'll be some things, I think. And that's totally an area where there's total freedom for people to make little third-party libraries that you could link that do all sorts of things, right? That's the goal, is to make all of this stuff that is maximally expandable and that you can build on, and yet still has this foundation of being a strongly typed language that is very robust to, giving you good compile time errors when something goes wrong. For a function that takes 2 args plus a vararg array, could you expand an array so its first 2 elements go into the first 2 variables and the rest go in the vararg array? Right now, the compiler will not do that for you, and I'm not sure if that's a good idea. We'll see. If people end up wanting to do that stuff a lot, you can introduce array notation. Like you could say, you could pass to the function a sub 0 and a sub 1 and then a sub 2 dot dot, right? Or I guess if we're talking about spreading, it would be like that. This notation does not exist in the language right now, but it could. You could also write a function that just makes that, right? Because when I did the varargs calling varargs, right? Let's go back to that. When I did this thing, remember I did this thing up here with this new args? Instead of doing all that, if I had this syntax, I could say new args is equal to args sub n dot dot, right? That could be what that looks like. And then if you had earlier arguments, your earlier arguments could have been this first 3 that are in n, right? So you could have done like args 0, args 1, except of course this is not robust to when you pass 0 arguments or whatever, But yeah, these things are fairly straightforward, small extensions to what I've done so far, and we just have to see what people want and what works well and what doesn't work. Very curious to hear how you want to handle threading and tasks. That is a future subject. We've already gone really long today, so I'm not going to start talking about that. You showed 2 versions of print any, one for embedded using type info and one using the types enum. My question is, given 2 implementations of the same function targeting different systems, how can I define which one I should use in which case? Do you mean as a user of a library, or like what you should write? I think if you don't need the detailed information, it's maybe more robust to write the thing that is most versatile, right? So that version that doesn't dereference the pointers is the most widely usable, and especially if you're a library author, you might think about using that. However, if you want to navigate struct fields at compile time and that's just what you want to do, then it won't work in that version, right? You need that struct field at runtime, and it's totally cool to use that. For the game that I'm making, I would probably do the second version that does it at runtime, probably. And I would probably, at startup, build some easily navigable tables of those things or whatever. That's essentially what I do now, except with really ugly macros and horribleness that you have to do in C++. It's up to you as the, what's your style and how do you like to do it, really. What's left before I share a public version of the compiler? Well, we have to have native backend, again. We have to have threading and good support for threading in some way, meaning doing more than C++ to help you avoid threading bugs. And if you watch the first couple talks, you might see some hints at what kind of things that might be. And I think we need some facilities for metaprogramming, like either generating code at compile time, or polymorphic types and functions, or both. or neither, and something better that fills that role. And then I think once we have all those things, maybe that's starting to be pretty good. And then I could release it for experimentation. But I want it to be a powerful, useful language before I put it out there. And at the rate it's going, that'll happen before too long, right? I mean, like I said, this is my spare time project, and it's kind of a nice language already. Like, it's nicer than C already, by a lot. You can't quite do everything that you can do in C++, but we're not far from that. And we're tremendously simpler. Like, how many lines of code is the last C++ compiler you heard of? This one is 14,000. So, yeah. Did I consider multiple return values? Yeah, in the first couple talks, I talked about multiple return values and said I would like them. It's just, they don't seem like that high of a priority compared to these other things. They're a nice to have, but they don't massively increase my power, so I'm saving multiple return values for later. Is that the end of the questions? Yes! I get to stop talking, which I would like to do. Thank you, everybody, for coming along. Thank you, those of you who showed up early, for watching a little Garth Marenghi's Dark Place with me. I'm not going to talk about threading. That's a different subject. Thanks for coming by. This video will be on YouTube tomorrow for future reference. And I am going to go rest my voice. And email me again at, which buffer was it in? Which ASD? Email me at language@tekla.com with non-syntax related ideas and questions and comments. And as always, I always encourage other people to talk about their own language ideas on the web. You know, it doesn't just have to be me sitting here with a megaphone. You could post on a blog or on Twitter or something. And I like to get discussion going about what's good to have in a practical, reality-based programming language for high-performance programs. I think we need more interest in that area and more discussion in that area, because most discussion lately has gone to the other end of the spectrum, like garbage collected, very high level, you don't know exactly what your output code is kind of languages. And at least lately, as myself and Casey Muratori and some other people have started expressing a lot more interest again at this end of the spectrum, there's been a lot of positive response. And so I'd like to see more people talking about that stuff. So, good night. Thank you, everyone, for coming by. And I will hand us over to Handmade Hero now.